This morning, I think we heard a wonderful opening keynote speech where we heard a designer articulate in a very engaging manner the process he went through to produce a visualization which we saw and we can see at the exhibit later this week. And I personally find that a very useful experience to get a glimpse of that design process that designers go through. And it prompted the question, why don't we do this more often? In other words, why don't designers share the process through which they came up with their visualizations in a more routine manner? When they do, it seems to be very effective. And it's not just the star designers, like we heard this morning and this afternoon, where that experience is useful. Every one of us, when we produce some data visualization, are designing something. And what I'm interested in is how can we capture the thoughts, the processes, the experiences that we go through, all of us, when we're creating things, in order to, if you like, advance the discipline and practice of visualization and sharing the experiences that we learn from. So within the next 30 minutes, I want to do two things. I want to make the case for a shift, perhaps, in the way in which we do visualization that takes into account the value in articulating how we design things. And secondly, I want to show you some software that hopefully makes that process a little bit easier. Now, in common with, I suspect, many people in this room, I'm interested in visualization and storytelling largely as a way of conveying our insights into data through visualization. In other words, we tell data stories, and it's what journalists do all the time. And what many of us who design visualizations are trying to do is to use ideas of storytelling to make that process of discovery and communication of data insight more effectively through visual means. And in order to do that, many of us have to learn how to visualize. In other words, we learn about the techniques that we can use to construct the kinds of things we've been seeing today and more widely. And many of us are enthusiasts for the technologies that do that, and we share our knowledge of those technologies, and we consume that knowledge because we want to learn how other people do things. But if you like, these are all the how of data visualization. How do you construct visualizations? What technologies do you use to achieve various ends? Now, this is valuable, and despite the slightly provocative title of this talk, I don't want to dismiss that. I think it's critical to what we do. But it does, I think, prompt the question, why is it that there are not so many of these resources for the why we build visualizations, and why the design processes, the questions we ask when we're designing things, why do I want to do it this way and not that way, rather than how do I do it this way and not that way. Now, there are exceptions, and we've heard Mariah earlier this afternoon allude to that in some of the models and experiences that she was relating, and indeed the book that she was reluctant to plug, I will plug for her as well, in that the case studies in particular are good examples of articulating those why questions. So they do exist, but I don't think they're as common as the how questions. And I think partly it's because this is actually how we do a lot of our at least the non-experts, a lot of our visualization designs, we experiment. Now, I don't, it's slightly comic, but of course it's valuable. We try stuff and we experiment and we fail and then we sometimes succeed. And so what I'm interested in is how can we capture that process as well and share that process and learn from others who've gone through that process. Now, of course, I'm not the only person to ask these questions. And think about how we might do it. I quite like this diagram, which comes from a more general description of design, not necessarily limited to the kind of designs we're talking about. But if you like, one of the objectives I have today is to make the case for at least sitting somewhere on step 3 and maybe beyond in this design ladder, where we're thinking about design as something that's absolutely integrated into the process of production. And what I'm going to argue is that the systems we often use, they don't support that as well as they could. And I think one of the reasons for that is that if we are developing visualization with these kind of computing technologies, the systems we use to do so encourage this kind of private dialogue. And it's a private dialogue in the sense that we instruct the computer to do things, we get some kind of feedback from the computer, maybe debugging information, maybe the results of what we've created. But that's a fairly closed loop between a person and a machine. And even those processes that deliberately try to bring in other people into the design process, whether it's through elicitation, requirements elicitation, whether it's through user feedback evaluation, I would argue that that often is still a sort of peripheral or secondary part of this process, because a lot of what we do is that inner private dialogue there. And even in distributed systems, whether using Git or some other technology that allows people to communicate, they're often just a series of these private dialogues between person and machine. And in a way, I think it kind of loses we don't capture the necessary direct communication of experience that perhaps would make the transfer and development of visualization as a practice and discipline more effective. And so what I am hoping for is to think about, well, what can we do with our technologies and our practice that mean that the primary dialogue is between people, and that the machine that we use to create our visualizations supports that, but doesn't actually drive the nature of this dialogue. So let me give you an approach which I'm calling literate visualization that might allow that to happen. And the term I'm using, literate visualization, comes from, or is an evolution of, I think, something that many of you will be familiar with, the idea of literate programming, which came from Donald Knuth in the 1980s, where he said that when you program a computer, if you just write code to get stuff done, you're missing out on an opportunity to really articulate, well, why have you designed your code in this particular way? And what he encouraged, or what he developed, was a system where you write as part of the coding process, you write plain text to describe what you're doing, as well as the machine instructions that get what you're doing actually achieved. And he called this literate programming. He developed a system to do that. And I think the critical characteristic of it, he had a number of sort of principles that drove what he suggested we should do. But the principal one to me was that he promoted textual narrative as a first-class citizen in a document. In other words, we don't just put comments into code as a sort of secondary device. We write our textual narrative first, and we fit in the code around that. And importantly, he said that if you do that, if you create a system effectively that supports this, the narrative sequence is determined by you as an author of a piece of storytelling, not by the constraints of the programming language. And I wanted to see how we can apply this in the visualization context. Now, some of you may be thinking, well, we do that already. We've got technologies to do that already. And indeed, the emergence of the notebook, whether it's the Jupyter notebook, the R notebook, or Observable, and I don't think it's a coincidence that the Observable workshop with Mike sold out very quickly, because there's a real demand to explore the potential of these technologies, where we are not just creating visualizations, we're not just writing code, we are writing something more than that, a narrative that fits those together. And you could argue that this is the legacy of Knuth's literate programming in the visualization context. And I think it is, and I think it's valuable, and I think this will do a lot of what I hope we can do in terms of a slight shift in our own practice. But I would still argue that the context in which most of these technologies are introduced and are used are really about that other form of storytelling, which is the sort of data analysis storytelling that drives a lot of our own visualization. They tend not to be orientated around the design narrative in quite the same way. There are kind of how-to questions, there are sort of tutorials that explain how to do things, but not necessarily documents that really articulate why we do things using these technologies. So what I want to move on to is to think about, well, how might we tweak the sort of designs of some of these notebook-type environments to really support the way we actually go about the process of designing our visualizations. And I'm going to do this by describing a piece of software that I've written and is available called LitFace, which supports this literate visualization approach. All of the examples I'm showing here are available on that website, plus many more, and you can explore this and run this code yourself. So LitFace is really designed to be something that a coder is going to use. It sits in a coding editor, and the examples I've got so far work with the Atom editor and the Visual Studio Code editor. So this is the start point. This is the environment that traditionally encourages this private dialogue between person and computer, where you're actually writing the code to do stuff. The details of the text aren't that important at the moment. I'll lead you through the structure in a second. And broadly speaking, this is the Atom editor, which many people use for coding anyway. You have two panels. We've got the coding panel on the left, where you're writing your code. You get debugging feedback and linting and syntax highlighted code, etc. And then we can also preview a formatted version of the code on the right, and those two are synchronous. You make changes to the code and the visualizations adapt. So let's just look at the different components. We have the coding environment where you write your code itself. It can be linted, it's reactive. Debugging error reports are highlighted when they occur. And they generate renderable output, which are asynchronous in the preview window. We have narrative text using the Markdown format. One of the advantages of Markdown, I think, that's probably a step forward compared with Donald Knuth's view of using tech to write the narrative, is that it's readable in its own right. You don't have to preview it in order to make sense. You can just read it directly. And it's relatively intuitive and easy to learn to use. That renders a stylized version of the text in the preview window, and you can have, within LitViz, you can control how that styling works with CSS. And we also have something called narrative schemas, which I will talk about a little bit later. But those are ways of embedding particular behaviors and rules into the way we construct our narratives in this environment. Just in the same way as a coding support embeds rules about how that code should work and how it behaves. And while this isn't a feature of LitViz directly, I think it's a consequence of the environment, which is that it does encourage this process of reflection and thinking aloud. And that's one of the main motivations for designing this and thinking about literate visualization, is making that what once might have been a private dialogue, a public one. Even if it's a kind of reflexive one that you're talking to yourself, that you are jotting down your thoughts as they occur to you. And that's quite an important principle behind the whole environment here, which is that unlike these very nicely crafted Keynote we heard this morning and some of the other talks today, which, if you like, are a retrospective picture of a process someone has gone through, and a very persuasive one, this is designed to generate that at the time you are creating. In other words, it becomes a living document that documents the evolution of a design as it's created over its lifetime. So let me just break down some of these in a little more detail. I'm not going to go into lots of detail because it's all available on the website, but I want to say a little bit about how we specify the visualization side, given this audience here. And I'm using something that was developed that Arvind mentioned in the introduction called Elm Vega, which is an interface to the Vega and Vega Lite software specifications for specifying visualization designs, and it uses this statically typed functional language called Elm to do so. And I'll give you a couple of examples to show why I think that might be useful. So anyone who's used Vega Lite will find this very familiar, simple example from a standard data set. And this is how it's expressed on the left in Elm Vega within this LitViz environment. There's quite a direct mapping. I designed this so that there was quite direct mapping between Vega Lite and the way it's expressed in this Elm language, which, being functional, has all the advantages as a pure functional language, that come with that. And in particular, it allows you to do something which I think is more difficult to do if you would otherwise work with the direct JSON specifications of Vega and Vega Lite directly. And it allows you to compose some of these expressions, these specifications, and parameterize them and reuse them, reshape them within the lifetime of a document. And importantly, it allows you to decouple the sequencing in which you specify your code from the narrative sequence that you might want to construct if you're producing one of these documents that tries to capture the whole design and build process. As an example of how this might work, this is also Elm Vega, but what we're using within LitFace is our parameterized function calls to some of those specifications. So it allows you to reuse functions, changing different parameters, in this case a set of map projections, embed them within the markdown text so that you can have a kind of rich integration between your visualization and the textual narrative here without having to specify lots of JSON over and over again. We can do that in a number of ways. So we can use spark lines here, for example, and they can be reactive. And if you're using the Vega version of this, then they can also respond to real-time data. And they can be integrated into the narrative as we see fit. So as I said, there's more detail about actually doing that, tutorials to get it working on the website. But I just wanted to give you a glimpse of some of the design choices that I made with LitVis in terms of the technologies used to create these visualizations. But what I want to do for the remaining time is to think about, well, what does working in a style, a literate visualization style, actually mean? Well, I've already mentioned it, but this idea of experimenting with our designs is critical, as anyone who's done this knows. That the ability to try things out and make mistakes and learn from those mistakes and try something else is really quite important. And to give you an example, again, the detail of the text isn't critical here, but I just want to show you the principle. So using an example prompted, in fact, by Lisa's recent article on dual-axis charts versus connected scatter plots, imagine you're wanting to show income inequality. You've got two variables, the income of the richest 5% and the income of the poorest 5%, and that changes over time. You want to see how that's changed over 50 years. So you've got three variables to consider. We might go through a set of design choices that say, well, let's have a time sequence, time on the horizontal axis, and then we'll show the richest 5% as a blue line, the poorest 5% as a red line. We might show those as separate charts, but if we want to compare the two, then we've got to move between the two. We've got to readjust the fact that the scales are different. So perhaps we might choose to put them on the same scale, which is the third chart down there. Then we've got the comparison, but then we've lost some of the fidelity of the poorest 5%. So perhaps we use a dual axis chart, but then there are problems with that, as we know. So we're experimenting with design choices. And we might use that document, that LitVis document, to document all of those choices as we perhaps make a final choice. But in fact, that might not be our final choice. We might take a completely different approach. So we might author a separate document that takes that alternative approach instead. Now, that separate document might be the same designer. They might be being authored in parallel. It might be the same designer 6 weeks later. It might be someone else on a team designing it, to the same objectives, but perhaps a different approach. And they might use this connected scatter plot, and they might use interaction, they might use anything else. But the point is, we've now got two parallel tracks of development here within this LitVis environment. And we wanted to support this by allowing these documents to be assembled that reflect those parallel experimental tracks. So at the start, at the top of that diagram on the right here, we've got perhaps something that's common to both of those tracks, so that the ability, the choice of data and maybe setting the objectives of what you're trying to do, maybe something that is common to both. And then we deviate down these two paths of design. We've got two documents that identify both of those parts, and then at some point in the future we might make a choice as to which one might be more appropriate. And we might justify that choice. So we can choose which pathway to work our way down there. Now, there's a mechanism in LitVis to do this. We have this idea of following, so a document can follow another one, which basically connects them together, as on that diagram there. And importantly, Well, this allows you to have arbitrarily complex trees of design choices. And importantly, this documents not only the successes. You might decide, well, actually, all the way down to leaf B is the way that I'm going to design my final product. And traditionally, that might be all that everyone else sees, is the bottom is leaf B, your final result. But we've managed to document synchronously, as we've developed our design, all these other failed attempts or design choices. And I think that's valuable, because I certainly learn from my mistakes and other people's mistakes. So why don't we share those? Why don't we capture those? Let's embrace that failure, and let's document it, and let's share those dead ends, if you like, because they can be valuable. So the final approach to thinking about literate visualization as a practice that's supported by LitFace is to think about how we structure our narratives. The text and the ordering in which we present our arguments or present the descriptions of our design choices. Now, I think this is important because, well, anyone who's involved, all the journalists here, know how important it is to structure narrative in a persuasive and communicable way. But when it comes to these kind of notebook environments, I think it's interesting to note, this was talked about Kai this year, a study looked at 1 million or so, in fact, nearly 1.5 million notebooks, Jupyter notebooks, I think. And they found that even though the facility exists to integrate text and code, a quarter of them, 250,000 odd, just contained code. They were just being used as a coding environment. They weren't exploiting the ability to mix textual narrative with implementation. And there must be a reason for that, and they look at some of those reasons. And one of the things that we've added to LitViz to try and encourage the integration of the textual narrative with the coding process is this idea of narrative schemas. And you can think of a narrative schema as being a set of rules that help you structure the content and form of a LitViz document. It's expressed as a YAML document. Now, this can be something you can write yourself, or it can be one of the existing narrative schemas that we've provided. But essentially, they contain 3 different parts. Labels, which are the components that you choose that you want to identify inside your document. Rules that say how those labels are going to be applied within your document. And then styling, which says how they're going to appear on the screen. Now, this allows you to, for example, to define a dialog schema. And we heard, first thing this afternoon, an excellent example of how dialogue can work when we're using the kind of rhetorical device of disagreement to explore choices. And we can, if you like, enforce that within a document by saying, well, I'm going to create a document that has to follow these rules. It has to have 2 voices, and those voices have to alternate backwards and forwards. If you hear from voice 1, then the next thing you have to hear from is voice 2 or voice B. Now, we can build those rules in, which just act as a sort of nudge when you're thinking about constructing your narrative to follow this particular design. And one of the motivations for doing this was to have something equivalent to those linting errors and debugging errors you get when you're coding that say, well, hang on, this wasn't designed to work this way. Look what you're doing here. We can do the same with our textual narratives as well. You were going to create a dialogue, but look, it's Amanda's doing all the talking. So it's a way of just steering you perhaps to follow something you've decided to adopt as an approach. We can compose these schemas, so you can build up higher-level schemas based on these simpler rules. So here we've got an example of Socratic questioning as a form of dialogue, where you have a naive questioner, Socrates, who says, well, why are you doing it that way? I don't understand. And you have to say, well, I'm doing it this way, and you have to explain. And that's a useful, again, rhetorical device, but also a useful device for prompting critical thinking. And you can build these up at higher and higher levels. So I would like to see that one day we can have some of the models that Mariah's been talking about, these high-level models of how we go about the process of, well, the entire process of thinking about matching task to visualization design. This is how it looks in practice. We embed some of those labels in the code on the left, and then they get formatted, and you'll get linting errors if you don't follow the rules that you've decided to follow. We can apply this in all sorts of contexts. If we've got a new design, or as perhaps we should call it, a xenographic, we can prompt ourselves to ask to describe that design in a particular way. We might say, well, if you follow this idiom schema, the first thing you must do is state the aims of your design. What are you trying to achieve? And if you don't, your document will flag up the fact that you haven't yet done that. And then we might have to say something about how it works. Doesn't really matter this particular example, but you get the idea that you would have a description of your idiom. And then we might provide some archetypes that say, well, if your idiom is presented with this form of data, it should look like this. So you get to learn how to interpret the graphics. And then you might be forced to say something about the limitations. So it's just, again, it's sort of scaffolding, if you like, to think about constructing a reasoned argument as part of that process. And then you can get on to the storytelling that perhaps we're more familiar with, which is then to apply your visualization to uncover insight. Final example of a schema is one that we worked with in GeoCenter and with other colleagues on a European project, where we can think of that dialogue not just between designers or even the designer themselves, but between the author of the visualization, but also the experts, the domain experts who might be using it, who have an important input, of course, into design. And this was used, we experimented with this with some crime analysts, police forces in this European project, where we were presenting a form of mapping that had some signals on top of the mapping, and we wanted the experts themselves to be able to shape the design a little bit. And in this case, a simple case of just shaping the opacity of the background map in relation to the signal in front. And that can be captured in the document, again, capturing another form of the decision-making that went behind what might ultimately be the agreed design. Okay, so I've presented hopefully an argument for why we should be thinking about articulating our design processes, and I've given you some software, a description of software that might ease that. Let me just summarize then by saying that I think design exposition, the ability to articulate our choices, will be a valuable way in which we can advance practice in our discipline and in our work. And I'd like to see more of that. I think that will be healthy for us. I think literate visualization, whether it's through an observable type notebook or whether it's through something like LitFace, eases that process by integrating the construction of a visualization with the reasoning about its design. And not just doing that retrospectively, but doing it as part of the process of construction itself. And that the particular support through branching to encourage experimentation and schemas to guide people through the narrative construction, I think, is a valuable one. Right, I was going to end it there. I've just looked at my timer. I've got a minute left. So I'm just in the spirit of design exposition. I will leave you with one final slide, which tries to articulate a little bit something about my own design for this talk, because I want to leave you with hopefully the message that it is in our interest to think about design exposition and to share our design experiences. So I will do the same with this talk. Thank you very much.